Greetings, Jahim. Greetings. Greetings, Jahim. Greetings, Giovanni. Can you hear me?
Yes, sir.
Afternoon, sir. Yes, I can hear you, sir.
Can you hear me, Jahim?
Yes, sir. I can hear you.
I'm not hearing. Greetings, Jahim. Can you hear me? Greetings, Jovan.
Afternoon, sir. Are you hearing us?
All right, I think something wrong with my headphone. Give me a second.
Sir, can you hear me now?
Yes, yes, I can hear you. All right. We're going to be going through the 2009 paper. As I tell you, we're going to start go through some. We're going to start go through some long time paper because, as I noticed, the long time paper them I repeat, and I have a strong feeling that these are the questions that might be coming back. All right. So we're gonna go through this 2009 this week, next week some more, probably a later paper, but I really want to look at 9, 10, and 11, all right, over the next 3 weeks. And guys, I really believe we can get the ones them. We just have to get serious from now. As I tell you, paper one, I'm gonna try to get some physical copy and bring in by the end of the month. And so we can have paper one them to start SWOT and have the actual paper instead of just the soft copy them. I might print 2 soft copy and ask that you guys photocopy them for the rest of our classmates. All right, I'm gonna print all the papers then because I have all of them up to 2020 for paper one. All right, so we're gonna start, and it started relatively easy. It says without using calculator, simplify.
Sir.
Yeah, can you hear me?
Yes, sir.
I think it's something wrong with my headset. I really don't know what's wrong with my headset. And I don't want to plug it out. I don't want to plug it out at all. All right, but let's continue. Something wrong with my headset. Gonna have to get a new one. It says, without the use of tables or calculator, simplify the root of 28 plus the root of 343 in the form k root 7, where k is an integer. So, and that's a whole of 5 marks, 5 marks. So let's shell down that one really quick. All right. So it gives us the root of 28, root 28 plus the root of 343. And I'm set to simplify this in the form k root 7. First thing we have to realize is that the root of 28, we can break that up. We can break up 28 as, I think this can written as
Root 7, sir.
Root how much?
4 root 4 times root 7, sir. Or just 2.
4 times root 7, good. Root 4 times root 7, good. Plus, how can we break up 343?
49 times root 49.
49, beautiful. So it's the root of 49 times the root of 7. Wonderful. Oh, so that means the 7 cubed is 343. Nice. So the root of 4, we know that is 2. And this becomes 2 root 7 plus the root of 49 is 7. So that's 7 root 7. And then if you're adding root 7 and 2 root 7, you're going to end up just get 9 root 7. So that one easy. And this is 5 marks. I don't know why it's 5 marks, but it's 5 marks. Where k is an integer. So right here, so we're going to tell them that k equal 9. Yeah, k equal 9. Just tell them that k All right, sorry about that. The program just closed automatically. I'm going to reopen it right now. It's just taking a while to open up. All right, this is giving some problem. I think I'm going to open it with Microsoft Edge. All right, I don't know why it's giving so much problem today. Let's open it with Microsoft Edge. Oh, it's now open. All right. Sorry about that. All right. So sorry about that. So we end up this was 9 root 7. So we can actually tell them then that right here. So we can tell them so k equal 9. All right, because k is an integer, you can tell them we work out so k end up equal 9. Now look on the easy 6 marks here now. It says simplify x to the 4th minus y to the 4th. Now you see a question like this now, divided by x minus y. There's a formula that I told us to remember. All right, very important formula. A to the n minus b to the n. We have to remember that formula. It comes in very handy. Remember a to the n minus b to the n. And remember we said that that is equal to, in bracket, a minus b, close the bracket, multiplied by, it's a to the n minus 1, b to the 0, plus a to the n minus 2, b to the 1, which is just b, plus a to the n minus 3, b square, and this continue all the way down to when we no more a, then it reach plus until it just reach b to the n minus 1. This formula is critical, all right? Important. So now, what does that mean? That means if you want to simplify, so part 1, part 2, if you want to simplify x to the 4th minus y to the 4th, you have x to the 4 minus y to the 4. Using that formula, it's going to be equal to, in bracket, x minus y times, in another bracket, it's going to be a to the n minus 1, which is going to be x to the third power, put in x as your a as x, plus a to the n minus 2 is x squared times b is y, so you get x squared y, plus a to the n minus 3 is x to the n is 4 minus 3 is 1, times b squared, which is y squared, plus, now realize next is when you put n as 4 minus 4 gone, so we just get b to the n minus 1, and so that becomes plus y cubed, and we're done. Now it did want to divide this by, so let me put it over now. We did supposed to now divide this by x minus y. So to divide this by x minus y is the same as dividing this by x minus y. So look at this now. This x minus y would cancel this x minus y. So look how, guys, look how easy this work out for 6 marks. You know why 6 marks? Because Cape thinks that people don't know that formula. Cape think everybody gonna use difference of 2 squared. But look, I showed you this formula for module 3, so we can factorize easily. So look how that work out easy. This is now x cubed plus x squared y plus xy squared plus y cubed. Easy as that. Soft. Capital T. Soft. Right? This is 6 marks. These are 5 marks, you know? And this are 6 marks. We literally do not now we get 6 marks. Literally. Right? Nothing. Alternately, you could have done it this way. So this is like a or. Alternately, you could have, maybe you never thought of using that formula. You could have said x to the 4 minus y to the 4 is, using difference of 2 squared, it is x squared minus y squared multiplied by x squared plus y squared. That's using difference of 2 squared. But then we also notice that x squared minus y squared can break down further. And so we end up get that x to the 4 minus y to the 4 is now x minus y times x plus y times x squared plus y squared. And then now you can, of course, divide this by your x minus y. Then when you divide by x minus y, them cancel. So any way you prefer to do it, it's up to you. You can divide by x minus y, divide by your x minus y. So see it there, this cancel, and so another answer we get from the OR method is that we can conclude that x to the 4 minus y to the 4 over x minus y, we can conclude that we end up get that it's equal to x plus y times x squared plus y squared. All right, and if you want to expand it out, guys, x times x squared is x cubed. Continuing from over here, x times y squared is xy squared, xy squared, and then now y times x squared is x squared y. This is now x squared y, and then y times y cubed is plus y cubed. All right, nice. That's what you get right here for x to the 4 minus y to the 4 over x minus y. Either way, you get a 6 marks. This or this. Which way was easier?
Sir, the first one was easier for me because I can remember the formula.
Yeah. All right, nice. So I agree. The first one is easier for me too.
Actually, did this question before the same 2009. I just use a formula.
Yeah. All right, I prefer the formula too. Definitely agree with you. Preferring the formula. All right, so that is that. 6 marks to do nothing. Then it says, hence or otherwise, we need to show that y plus 1 to the 4 minus y to the 4, work out to do this formula. It's a hence. If you're going to use hence now, that means, remember, writing down what we just said, using hence, it said hence, meaning don't use nothing else. Use the answer we just generate. We end up just generating x to the 4 minus y to the 4. Writing down the formula, we said that it was equal to x minus y, and this was multiplied by, in the bracket here, x cubed plus x squared y plus xy squared plus y cubed. All right. Now it says hence. Hence, we're supposed to work out y plus 1 to the 4 minus y to the 4. Since it's a hence, what we're going to do is replace x with y plus 1. You're replacing x with y plus 1. Replacing x with y plus 1, what you get is that it's equal to y plus 1 minus y, all right, multiplied by, this becomes y plus 1 all cube. This becomes now plus x squared is now y plus 1 all square multiplied by y plus this x now is y plus 1 times y squared plus y cubed. All right, and that's it. Nice. Now that we get this now, we realize that y plus 1 minus y, this minus y and the plus y gone. So it just work out to be the answer we them want. It work out to be y plus 1 all cube plus y plus 1 all square, y plus 1 all square times y plus y square, y plus 1 times y square plus y cube. So we end up get the answer what we want. So we're nice. All right, we're nice. We're literally nice. All right, you can tell them soft. This is a giveaway 4 marks. 4 marks for this, you know. Christmas time, right? Christmas, early summer, everything. Easy, soft. All right, let's look at what they say next now. All right. All right, I don't know what's happening. I think it's what's wrong with my microphone. Each time it shifts, it keep like freezing and blocking the screen and all sort of something. Don't know what's wrong with my microphone. I think I really don't want to plug it out because the audio is not so good without it. All right, let's see. Let's hope it don't do that again. All right, so we don't do this, and we do this. Deduce this. Now we need to deduce that this right here is less than this. Now that is easy. So let's write down what we're supposed to prove. So we want to prove that this right here, we want to prove that y plus 1 to the 4 minus y to the 4. We want to prove that this is less than, so this I'm writing down RTP, meaning required to prove. We want to prove that this is less than 4 times y plus 1 all cubed. Four times y plus 1 all cubed. All right, I think I'm gonna have to plug out the audio. Give me a second. I'll close some programs. Just gonna close some windows. Gonna close some windows. Close this calculator. Plug out the audio. All right, I think we should be fine now. All right, we should be fine. So this, we want to show that it's less than 4 times y plus 1 all cube. Now to show that it is less than 4 times y plus 1 all cube, all you need to do is, remember, you have your left hand side, all right? You need to show left hand side is less than right hand side. So if this is what you want to show, you can test it. So let's test it out. To test it out, remember that all of this is this up here, right? All of this is this. So what you're going to do is replace the left-hand side with y plus 1 all cube. Y plus 1 all cube plus, this is y plus 1 all square times y. This is then plus y plus 1 multiplied by y squared. This is a left, by the way, let me write LHS. We're trying to show that our left-hand side is less than the right-hand side. So this is our left-hand side times y squared plus y cubed. All right, so simplifying our left-hand side now. So if you were to expand out all of this, you're going to show that the expansion of your left-hand side is less than your right-hand side. But first thing, you need to know what your right-hand side is. What is your right-hand side? Let's expand out our right-hand side just for a second. All right, you can't prove that the left less than the right if you don't know what the right-hand side work out to be. Y plus 1 all cube, if you check a stack, this is equal to y cube plus 3y squared plus 3y plus 1. Remember the formula of how we expand it. All right, it's the first term cube plus 3 times the second term squared times the 3 times the first term squared times the second term plus 3 times the first term times the second term squared plus the second term cube. They'll multiply all of it times 4. So this is what is right hand side. 4 cube plus 12y squared plus 12y plus 4. This right here is our left-hand side. All right, cool. So now we just need to simplify our left-hand side and show say it less than that around there. It's supposed to be less than this. Now let's go ahead and expand it and show us so we're going to get that it's less than that. Expanding this now, we know so our left-hand side going to be y cube plus 3y squared plus 3y plus 1. Then this right here, y plus 1 all squared times y. Y plus 1 all squared is y squared plus 2y times y. Y squared times the y would give you a y cube plus, in the middle would be 2y. 2y times y is 2y squared plus 1 squared times y is y. Then plus y plus 1 times y squared is y cube plus 1 times y squared is y squared plus another y cube. Now look at this now. Y cube, let me put it in a different color. This y cube here so, this y cube here so, this y cube here so, this y cube here so is 4y cube. This work out to be 4y cube. And then this, your y squared them is 3y squared, 4y squared. This is then plus 4y squared. And this right here so is, where's our y term? 3y, and y is 4y.
So
Oh, I forgot to add the 2y squared down.
That's it.
Yeah, so that would make it 6y squared.
So isn't there supposed to be like a next two, sir?
Another 2, where?
No, sir, as in the thing they had right there.
This?
So
Yeah,
that's
let's put
4y
it in it.
squared.
6y squared, yeah. All right, nice. Then the 3y now, and the y is a 4y. So get plus 4y plus 1. So guys, this is our left-hand side. Clearly this is less than right-hand side. So let's finish it off now. So remember, this is your right-hand side, you know. So we can tell them this is how you're going to write it mathematically now, guys. It often makes sense. Please make a statement that makes sense. You can't expand out your left and just tell them, say, less than the right. What you're going to have to tell them now is, so your left-hand side, work out, say it's equal to 4y cube plus 6y squared plus, I think that was 4y plus 4y plus 1, yeah? Now, what you're going to tell them now is, please, you have to tell them this. Tell them, say, it is less than the 4y cube plus the 3y squared times 4. Yeah, less than the 12y squared plus the 12y plus the 4. Yeah, right? You can tell them to call, look, this half less than this. The 4y cube and the 4y cube, them would have cancel. 6y squared half less than 12y squared. Because if y squared and y squared are the same, this must be bigger than this. 12y half bigger than 4y, 4 half bigger than 1. That makes sense? This makes sense, right?
Yes, sir.
But over this side, remember, this side was what? All of this expansion was 4 times y plus 1 all cubed. This right here was 4 times y plus 1 all cubed. That's how you make a statement. Then makes sense. So all of this side over here, which was the y plus 1 to the 4, we can end up tell them, say, yes, it is less 4y plus 1 to the 4 minus y to the 4. You can tell them now, say less than this. That's how you make it make sense. It have to make sense. All right? You can't make a statement don't make sense. Meaning you can't just expand the left, expand the right, and say, oh, them less than. This is how you do your proof. Show that your left is less than your right. Please, guys, I hope everybody do that properly. Show your left less than your right. Now this one right here, yeah, go ahead.
So should we substitute a value to show, sir, or do we not have to do that?
It said deduce, so you can't substitute. If it said show, then you could, but it said deduce. All right? Okay. So go through the syllabus and look at what it said. When it said deduce, what you're gonna have to do is some form of expansion to come up with a derivation to show the answer. All right? You can't just substitute. If they say show, then you could. All right? But it said deduce. The next part, this now, easy. It says solve the log equation. Log to base 4 of x equal 1 plus log 2 to log base 2 of 2x. Now you have to change the base whenever you get something like this. Anytime you get something with 2 different base, change it. I'm begging you guys, change it. Right? We're gonna get them ones then, but we just have to do all the questions to see what going on. All right, so this is log to base 4 of x. It paused because I was looking back at the question, equal to 1 plus, can't remember, let's look back at it. 1 plus log to base 2 of 2x. Log to base 2 of 2x. So this is what we want to do now. Now, working this out now, we can change the base from 4 and write it as, remember we did change of base today, it's log to base 10 of x. Well, we don't have to change it to base 10, change it to base 2. Log to base 2 of x divided by log to base
2 of 4.
Good. But look at this, guys. Log to base 2 of 4, right? Log to, why is it doing that? Log to base 2 of 4, if you have to check it out. Where's my calculator gone? Log. Why it not allowing me to press? Why I can't press the calculator? What's wrong with it? Let me close it. For some reason, I can't press the calculator. I'm gonna close the calculator for a second, then reopen it. All right, now I can press again. If we work out log to base 2 of 4, you notice that you'd get 2. So what we're virtually saying then is this log base 4 of x is log base 2 of x over log base 2 of 4. But log base 2 of 4 is just 2. You can just put 2. So it's log to base 2 of x over 2. That's understood? Cool with this?
Yes.
All right, now you see 1 right here, so now you can rewrite 1. Well, let's just leave the 1 for now as
So
1.
when do you write it as 2, sir?
Repeat.
Shouldn't you write it back as 2?
Do write 1 as 2.
No. Well, let me change it again. So log
Base 2 of 2.
of 2. Yes, sir.
You could, very good, you could. Now, there are 2 ways you can approach it. Just as Jovan said, you can rewrite this as log base 2 of 2, then you multiply through by 2 and get one entire log equation. You get log base 2 of x is equal to, when you multiply through by 2, you get 2 log base 2 of 2 plus, when you multiply through by 2, this becomes 2 log base 2 of 2x. We multiply it through by 2. Now we can end up write one log equation. So what we end up getting now is log base 2 of x is equal to, we can carry up the power up here to write this as log base 2 of 4. We'll bring up the power plus, bring up this power now, we get log base 2 of 2x all square. You have to bracket it 2x, you know, it's not just, it's 2x all being squared. Now by rules of logarithm, let's continue it up here. What we'd end up getting is this work out to be now log base 2 of x is equal to, this becomes, write it as 1 logarithms. It becomes log base 2 of 4 multiplied by, you see that 2x all square, this is 2 square is 4, so it becomes 4x square. We'll call it the 4x square.
Yes, sir.
Nice.
Yes, sir.
So this becomes now log base 2 of x is equal to, as we can see now, this is now just log base 2 of 4 times 4 is 16x squared. Now if log a is equal to log b, then a equal b. So that means x is equal to 16x squared. X is equal to 16x squared. Now, Mr. Platt is a big fan of doing this dividing through by x. Guys, don't divide through by x. Please bring it over and write it as a quadratic. 16x squared minus x is equal to 0. Please write it as a quadratic. Bring over the x over there. Then you can factor out x and we end up get 16x minus 1 equals 0. Yeah, man. So now what you end up getting is x is equal to 0 or x is equal to 1 over 16. All right, that's what you get. X equals 0 or x equal 1 over 16. But watch here, x can't equal 0. You can't find the log of 0. So this one is not valid. You'd write NV, not valid. So the answer is 1 over 16. All right, that's it. Easy, don't it? Easy, right?
Sir, could you show us how you got the log base 2 to the x of 2x over 2, sir?
This part?
Yes, sir.
All right, so using change of base law, let's write it back down. Remember change of base law? Log of a base of a number is what? This is
the log of the new base.
New base of the number divided by?
Over the log of the new base to the baser.
All right, good. So this right here now, what we did was rewrite. Let me separate it. Just put a box. All right, so what we did was rewrite this as log base 2, log base 4 of x. We rewrote it as, following this, tell me what it is. Log base 2 of?
Sir, it will be log base 2 of 2, sir.
Log base 2 of 4, log base 2 of? Log base 2 of what? Of x?
No, oh, x, sir. Yes, sir.
Yeah, the number is x over?
The log base 2 of 4, sir.
Now, what's log base 2 of 4? I showed you in the calculator. See it here? Log base 2 of 4 is?
2.
You see it?
Yes, sir. 2, sir.
Yeah, so that's how we get the 2. Cool with it now?
Yes, sir. Thank you, sir.
All right, nice. Yeah, man. So, guys, this is how you get your 8 marks. I don't even know why 8, but they're giving us 8 marks. But we'll take it. We're happy for it. All right, so question 1, that's it. Basically, algebra for 2009. All right, now here's a question that for some reason gave us trouble on the mock exam. All right, it says find a quadratic equation whose roots are 2 over alpha and 2 over beta. Now the first thing is, guys, if you have a quadratic equation 2x squared plus 4x plus 5, write it back down, 2x squared plus 4x plus 5. Then we already know the 2 roots them. Well, we don't need to find the 2 roots. But what you can do is, see it here now, all you need to know, sir, is that the sum of the roots, alpha and beta, alpha plus beta, is minus b over a. So alpha plus beta is minus b over a, which will give us minus 4 over 2, which gonna end up equal to negative 2. Yeah? Cool with this?
Yes, sir.
Then alpha beta is c over a. Alpha beta is c over a. So in this case, it is 5 over 2. And 5, that is just c over a, you're done. Now, them say we need a new quadratic. We need a new quadratic, new QE. NQE means new quadratic equation. New quadratic equation, and them say the roots is supposed to be, I think the root is 2 over alpha and 2 over beta. 2 over alpha and 2 over beta. Them say the roots to be 2 over alpha and 2 over beta. So the first thing is we need to find the new sum, right? So the sum of the new roots is going to be 2 over alpha plus 2 over beta. That's going to be their sum, 2 over alpha plus 2 over beta. And you're going to divide this now by alpha beta, so we can, you know, write it as one fraction. Like, why would you want to add 2 over alpha plus 2 over beta? Write it as one fraction. Alpha into alpha beta goes beta time. So we get 2 times beta plus beta into alpha beta goes alpha time. We get 2 times alpha. So what that works out to be is 2 in bracket alpha plus beta divided by alpha beta. Nice. This is what we end up get divided by alpha beta. Now alpha plus beta, we already established that's minus 2. So we get 2 times minus 2, and that's being divided by alpha beta, which is 5 over 2. Now I'm not going to work that out. We're going to put it in the calculator. 2 times minus 2 divided by 5 over 2. It's very lazy, but we had a long day, so everything we're going to do with the calculator now. Minus 8 over 5. That's what we get. Minus 8 over 5. Nice, minus 8 over 5. Now that we get minus 8 over 5, we need to find the product now. The product, we can call it P. So the product of the two roots is going to be 2 over alpha times 2 over beta. Now, anytime you multiply fractions, you multiply their numerators across to get that their product is 2 times 2 is 4. So you get 4 over alpha times beta. Now, alpha times beta is 5 over 2. So end up get that the product is equal to 4 divided by 5 over 2. Again, I'm not going to work this out. You're going to go to the calculator. I know it's lazy. 4 divided by 5 over 2. What? Oh, 8 over 5. So that's what we end up get for the product, 8 over 5. Now, guys, once you have the sum and the product, remember this, remember this, remember this. A quadratic equation is written in the form x squared minus the sum of the roots times x plus the product of the roots equals 0. So once you find the sum, the quadratic equation is going to be x squared minus the sum of the roots, which is minus 8 over 5. Minus 8 over 5 becomes plus 8 over 5 times x plus the product of 8 over 5, and that's equal to 0. If you want your answer look pretty, you can multiply through by 5 and write that the quadratic equation is 5x squared plus 8x plus 8 equals 0. If you want your answer look pretty, we can leave it like this. All right, just to leave our answer like that. We'll call it this.
Good afternoon, sir.
Good afternoon, Mr. Platt. You know, we just were mentioning something that you should never do, that you always do. Divide through by x here and get rid of the 0 as a possibility.
All
right, no problem. All right, so we're going through 2009 here. This is a long time paper. All right.
2009.
Yes, 2009 when you were a baby. All right.
Good days.
All right. Now, guys, this came on the mock exam, and I think only a handful of persons got this right. I don't know why, right? This is where I took this question from. All right. Of course, I change up the letters from U, V, W, X, Y, and Z, and I change it out a bit. And I noticed that we don't know what ordered pairs mean, or I don't know why we left it out, but I think 6 out of the 25 persons got this right. Express it as ordered pairs. All right. Now, ordered pairs mean that you put it in a set, pretty much. Put it in a set. So that's what we're going to do here. Let's put it in a set. Now, look at this. It says a coach of an athletic club trains 6 athletes, U to Z, in his training camp, and them get assigned to activities 1, 2, 3, and 4. Express as an ordered pair. F as an ordered pair would be F is such that it is given by as an ordered pair, or you can write F equal to, don't matter, write it as an ordered pair. We'll see that U get assigned to 1, so it's U comma 1. You always put your X first, then your Y. This is the domain, and this is the codomain. Then now the next athlete, V get mapped to 2, and V also get mapped to 3. V get mapped to 3. Nice. All right. Then we know say X get mapped to 1. X get mapped to 1. Then we say Y get mapped to 3. And then finally we say Z get mapped to 4. All right. And that's it as an ordered pair. Easy. That's 4 marks. This is not easy for 4 marks. Easy though?
Yes, sir.
Yeah. Then it says state 2 reasons why f is not a function. All right, most of us get the first reason in mock exam why f is not a function. Everybody tell me that f doubly don't map. All right, so that's pretty good. So the first reason why it's not a function is because W does not map. Now guys, I don't want you to write it like that. I want you to tell me this way. The question is about an athletic club. Make it stay realistic. So said f is not a function because the coach did not assign athlete W to any activity. All right, I still gave the mark. This is one reason why f is not a function, because athlete W was not assigned to any activity. Is that cool? Don't this sound proper though? Instead of saying W don't map.
Yes, sir.
Yeah, this sound proper. So that's how we should say it. Athlete W don't get assigned anything. Now the next one that person's missed out was V. Notice that V get mapped to 2 and 3. Now if it is a function, each element in the domain must map and map to only one element in the codomain. Athlete V is being overworked by getting 2 assignments or 2 activities. So that's another reason why it is not a function. So that's reason 1. Reason 2 is f is also not a function since athlete V is given 2 physical activities to do, right? So athlete V is being overworked. All right, that means that V is mapped twice. So that's why it's not a function. Now it says hence. It says by making minimal changes to f, construct a function g, which maps set A to set B as the set of ordered pairs. Now it says minimal change, don't make a new function. Minimal change just means you need to give double an assignment, so you can map double to any one of them, or you can take off V off of any one of them. That's all right? That's all. So let's just do that now. Now you can do it many different ways. You don't have to do it my way. You could do map doublet to I'm going to map doublet to maybe 1. All right, so this is going to be the function G. This is my domain. And the athletes who are the athletes again? It's...
So the problem was WMV, sir. W
U
was
go
not.
to Z. U go to Z. Thanks. U go to Z. So U, what's the next letter behind U? W. I don't know my alphabets. V. What's the next letter after V? U, W, V. There's one more letter. Let me see. U, W, U, V, W, X, Y, X, Y, or X, N, Y. I don't know my alphabet. That's crazy. Right? So this is it now. This is the domain A.
Sir,
And
behind
domain
W.
A undergoes the
Other way
function
around.
G. And we can construct the codomain now. And the codomain is 4 activities. 1, 2, 3, 4. Now remember guys, it said minimal changes. Minimal meaning anything with it all right, you don't trouble. Anything that was all right, you don't trouble. I keep emphasizing this because some persons change what was all right. So U map to 1, you don't need to change that. All right, U map to 1. V map to 2 and 3, that you need for change. So you can either map now, you can either map V to 2, or you can map V to 3. Whichever one it you want to use, that's fine. So let's stick with 2. Now double don't get what X was mapped to. X was mapped to 1, Y was mapped to 3, Z was mapped to 4. So put back that. So put it back now. We'll just put back X was mapped to 1, Y was mapped to 3, Z was mapped to 4. So this would be our function right here, and this is a whole of 4 marks. All right, so this is part 3. Nice. This is mock exam. Easy. 4 marks this, 4 marks to do this. Now here's the question that a lot of us left out, and some of us attempted but wasn't too proper. Determine how many different functions are possible in 2b. Now look how many different functions were possible. See the diagram here? Remember that we could have put v to either 1 or 2. That was a case. We could have put, sorry, not v to 1 or 2. We could have put v to 2 or 3. So v could have mapped to either 2, or we could have put v to either 3. That's already 2 possibilities right here. All right? Then also, doubling did need for map. So we could have mapped doublet to 1, we could have mapped doublet to 2, we could have mapped doublet to 3.
So, good question.
Or could have mapped doublet to 4. Yes, Jovan, go ahead.
The idea of ordered pairs and then count how much things we have in B set and say that's the minimum amount of supreme.
Can you repeat?
Here, I'm saying, so couldn't we, using the concept of ordered pairs, let's say there's 2 numbers, right? Couldn't we have the 2 raised to a certain power depending on the amount of times
no,
you get a function?
You can't just say to a power. No, you have to actually look at it to decide for how many. All right? You couldn't just raise it to a power. I get what you're thinking about, but no, not in this case. All right?
Okay, sir.
You have to write them out and observe what happened. All right? So you have to write them out and realize that, look at this, guys. Remember, it's 2 things occurring simultaneously. So V could have mapped to 2 and double mapped to 1 at the same time. Or V could have mapped to 2 and double mapped to 2. Or V could have mapped to 3. V could have mapped to 2 and double mapped to 3. Or V could have mapped to 2 and double mapped to 4. That's already 4 ways. Or it could have been V mapped to 3 and double mapped to 1. V mapped to 3 and double mapped to 2. V mapped to 3 and double mapped to 3. V mapped to 3 and double mapped to 4. So I'm going to write out all of them now, and you can see that the total possibility is 8. All right, so finally, the last part of part 3, you can tell them that there are 8 different possibilities. 8 different possibilities. Again, let me explain why. See it here now? I'm going to write it as a set of ordered pairs. We could end up getting V and 2 is 1 possibility, and double and 1. So them 2, they could occur simultaneously, or it could have been V and 2 and double and 2, or it could have been V and 2 or double and 3, V and 2 and double and 3. Do we see how it is 8 now? We getting the gist?
Not really sure. How come we don't use any of the other letters here?
The other ones don't matter. They say minimal changes. Minimal. The word minimal means that you don't trouble what would already make it be a function. It says determine how many different functions are possible in G2. G2 is this one right here that we do. G2, minimum changes. Minimum changes mean we don't trouble U, we don't trouble X, we don't trouble Y, we don't trouble Z. We only trouble V because you said in A that V map twice. So we need V to map only once. We need V to either map to 2 or V to map to 3, but it can't map to 2 of them. All right?
Okay, sir. Say again, sir.
Make sense?
Yes, sir.
All right, then double don't map. So double can map to anything, right? Make sense?
Yes, sir.
So that's what we're doing right here. We're showing all the possibilities. So we're pretty much telling them that, see it here, V can map to 2 and double map to 1 same time to make it be a function. Or V can map to 2 and double map to 2. or V can map to 2 and double map to 3, or V can map to 2 and double map to 3, or V can map to 2 and double map to 4.
And it can be the other way around, sir.
And then it can be the other way around now. So tell me the next other way around now.
So it could be V being 1, 2, 3, 4, and W being 2, 2, 2, 2.
It could have been V being what? V map to what?
To 1, sir.
No, 3. Remember V map to 2 and 3. So it have to be either we're choosing V map to 2 or V map to 3.
Oh, I just realized now, sir. Yes, sir.
All right, think about functions this way. Remember, well, I told my AdMath group this. It can't be a function if a girl, which is in the domain, have 2 boyfriends. She can't have 2 boyfriends. No, that's wrong. So what we say is either she gonna date with this guy or she gonna date this guy. So if you choose 2, then we look at all the possibility where she can date 2 and W can just have 1 boyfriend, either 1, 2, 3, or 4. Or let's say V did decide for date 3 and W can date either 1, 2, 3, or 4, right?
Yes, sir.
That make more sense?
Yes, sir. That's what you
That's
mean.
when it is a function. So always remember, that's when it is a function, right? One girl can't date more than 1 boy. All right.
Sir, I was thinking that V was mapped to 1 and 2 instead of 2 and 3, sir.
Oh, okay. I see what you're saying now. Oh, V was mapped to 2 and 3. All right. So that girl is crazy. She can't do that. Right. So looking at all the possibilities to make it a function, to make it right, meaning V after date 3. If V date 3 and W can still date 1, or I'll continue to write out the others when V is dating 3. All right, and that's how you'd end up get the 8th possibility. So see how this mock exam question is easy? Easy, don't?
Yes, sir.
Yeah, man, it did easy. Just to write out all of them. You didn't have to write out all of them, all right? You just could have just put that it's 2 times 4, which is 8.
Sir, you know what's funny?
Yeah.
Right before this exam in the morning, I was like, let me check the examiner sheet for 2009.
Yeah.
I tried my best to write down everything I remembered from the examiner sheet.
Whoa. All right. Nice. So that was this here. All right. Now let's go through this one now. So that is that. Now I'm really happy that, guys, most of us did this part really quickly. So let's just blow through it. Most of us did this really well, which is good. Find FF of 20. It tells us that when X is 20, you use the bigger function. So F of 20 would be plugging 20 in here, 20 over 4. 20 over 4 is 5. So FF of 20 works out to be F of 5. And F of 5 is when X is bigger than 3, we'll still put it in the second function, which is 5 over 4. Nice. The next one says F of 8. To get F of 8, we'll find F of 8 when 8 is bigger than 3. So we can put it in here to get 8 over 4 is 2. That's F of 8 in here. Then we'll find F of 2. But when it is 2, 2 is less than 3. So put it in the first one to get 2 minus 3, which is -1. Then FF of 3, when X is less than or equal to 3, we'll put it in the first one to get, this is going to be F of, put it in the first one, 3 minus 3. 3 minus 3 is 0. So it works out to be F of 0. And F of 0 is equal to, F of 0 is 0 minus 3 is -3. All right, and that's that, -3. Nice. Are we done? Cool with this? Make sense? Nice.
Yes, sir.